Welcome back to the final segment of today's conversation. Over the past hour, we've explored your journey into robotics, uncovered the realities of working in the industry, listened to memorable stories from real deployments, experienced a day in the life of a robotics startup founder, and looked ahead at the exciting future of autonomous robotics. To wrap things up, I'd like to ask one final question. If you could go back in time and meet yourself as a third year engineering student, what advice would you give?
I'd probably smile and say, don't worry about becoming an expert overnight. When I was in college, I believed I had to learn everything immediately. Every week, there seemed to be a new robotics framework, a new AI model, another programming language, or a new development board everyone was talking about. I kept wondering whether I was already falling behind. Looking back, I realized I was asking the wrong question. Instead of asking, how do I learn everything? I should have asked, how do I build strong foundations? Everything else grows from there.
That's reassuring because robotics can feel overwhelming for beginners. If someone asked you where to begin today, what would your roadmap look like?
I'd recommend learning in layers. First, understand the fundamentals of mathematics and physics because robots move in the real world and motion follows physical laws. Then learn programming. Not because programming is the goal, but because it's how you'll teach a robot to perform tasks. After that, explore electronics and embedded systems. Understand how sensors collect information and how controllers interact with motors and actuators. Once those fundamentals are comfortable, move into robotics concepts such as localization, perception, SLAM, path planning, sensor fusion, and navigation. Finally, learn how professional robotics software is developed using frameworks like ROS. Each layer prepares you for the next. Trying to skip steps usually creates confusion later.
Many people wonder whether mathematics is really that important. What's your opinion?
Mathematics is incredibly valuable, but don't let it intimidate you. Think of mathematics as the language robots use to understand movement, position, distance, angles, and uncertainty. You don't have to master every advanced topic on your first day. Instead, learn mathematics alongside practical robotics projects. When you see equations controlling a real robot, they suddenly make much more sense. Theory becomes far more meaningful when you can watch it solving real problems.
If you were advising someone to build their first robotics projects, what would you recommend?
Start with simple projects that teach one concept at a time. Build a robot that follows a line, create an obstacle avoidance robot, develop a basic autonomous rover, experiment with cameras and object detection, build a small mapping robot, create a simple robot using ROS. Try combining multiple sensors into one project. Every project teaches you something new. More importantly, every project builds confidence. Don't wait until you think you're ready to build something impressive. Build something small today. Improve it tomorrow. Keep learning.
Many learners worry about choosing the perfect programming language. Should they?
Not really. Programming languages are tools. Logical thinking is the real skill. Whether you begin with C++, Python, or another commonly used language, focus on understanding how to solve problems rather than memorizing syntax. As your career progresses, you'll naturally learn additional languages whenever they're needed. Good engineers adapt. That's far more valuable than knowing one language perfectly.
What personal qualities have helped you most throughout your career?
Curiosity, patience, persistence, and teamwork. Curiosity encourages you to ask better questions. Patience reminds you that debugging complex systems takes time. Persistence helps you continue when a robot refuses to cooperate. Teamwork allows people with different expertise to build something none of them could build alone. No successful robot is created by one person. It's always the result of collaboration.
What mistakes do you see beginners making most often?
The biggest one is comparing themselves to experienced engineers. It's easy to watch impressive robotics demonstrations online and think, I'll never be able to build something like that. What you don't see are the hundreds of prototypes, failed experiments, software revisions, hardware redesigns, and countless hours of testing that happen first. Every experienced robotics engineer has a long history of mistakes. Those mistakes weren't setbacks, they were part of the learning process. Don't be afraid of making them, learn from them.
We've talked a lot about careers. What advice would you give to someone who dreams of starting a robotics company one day?
Start by solving a real problem. Spend time observing industries, visit factories, talk to warehouse operators, speak with healthcare professionals. Watch how work is actually performed. Don't begin with, I want to build a robot. Begin with, what problem needs solving? The robot is only one possible solution. The real value comes from improving people's lives, making workplaces safer, increasing productivity, or solving challenges that are difficult or dangerous for humans.
As we reach the end of today's conversation, I'd like to ask one final question. What message would you like everyone listening to remember?
I'd like them to remember this. Autonomous robotics isn't about creating machines that replace people. It's about creating intelligent systems that work alongside people to solve meaningful challenges. Every robot you see today started as an idea. That idea became a sketch. The sketch became a prototype. The prototype became countless experiments. The experiments became a reliable product. Innovation is simply the result of curiosity combined with persistence. If you're fascinated by how things move, if you enjoy solving problems, if you like combining software, electronics, mechanics, and artificial intelligence, if you're excited about building technologies that can explore, assist, inspect, transport, and improve the world around us, then autonomous robotics offers an extraordinary career. Remember, no robotics engineer begins by building an autonomous warehouse or a planetary rover. They begin by learning one concept at a time, one sensor, one motor, one algorithm, one project, one lesson, and over time those small steps become remarkable achievements. Stay curious, keep experimenting, never stop asking questions, and most importantly, keep building.
That's a perfect way to conclude today's episode. Thank you for sharing your journey, your experiences, your lessons, and your vision for the future of robotics. To everyone listening, we hope this conversation has shown you not only what autonomous robotics is, but also why it's one of the most exciting and impactful engineering fields today. As you begin the learning journey ahead, you'll explore topics such as sensors, perception, localization, SLAM, sensor fusion, path planning, robot operating system, ROS, autonomous navigation, and intelligent decision making. Each of these topics may seem challenging at first, but remember what we've heard throughout this conversation. Every expert once started with the fundamentals. Learn patiently, build projects consistently, collaborate with others. Stay curious. The robots of tomorrow will be created by the engineers who begin learning today. Thank you for joining us for this episode of the Day 1 to Deep Tech podcast series. We'll see you in the next episode.